Good afternoon. My name is Brian Olson, manager of the Monsanto Water Utilization Learning Center in Gothenburg, Nebraska. Today I'm going to continue our series discussing basic irrigation principles by discussing irrigation water infiltration. So the purpose, we want to minimize water runoff and maximize how much water is absorbed into that soil while meeting the crop water use demands of a growing crop over the growing season. So when we're looking at this, there's some factors that definitely play a part in how much water is absorbed by that soil. And first is topography. So when we're looking at that field, is the field generally flat or rolling, or does it have some steep inclines? If we think of a field with steep inclines, for example, on most of the field, it's flat ground, and then we have some steep inclines on about a third of the field. If we go through there and maximize water uptake on that flat part of the field and do not make any adjustments when the pivot reaches that part of the field where we've got some steep inclines, we're going to see an excessive amount of water runoff because the soil will not be able to uptake that water that is being applied to that surface because, again, it is running off because of the incline. What about residue? Residue can be very beneficial. So back to that hill with some incline to it. If we've got some residue out there on the surface, it is basically slowing down that water as it hits the ground. Okay, so here we've got our water hitting the ground and it starts running down that hill. It runs into that residue, it slows it down, which allows for infiltration of that water into the soil. However, residue, if it's an excessive amount of runoff, no amount of residue will stop all that water from running off of the soil. So again, residue can be beneficial, but it's not going to eliminate runoff if an excessive amount of water is being applied. Then we can look at water quality. So if farmers are getting a new piece of ground with a pivot on it, and I would encourage them to take a sample of their water to see if they have good water quality, and also it'd be important to see how much nitrogen is being applied because a lot of the groundwater also has a little bit of nitrogen in it. So when we're looking at that water, if we've got a high sodium to calcium ratio, that's going to impede water infiltration compared to what we would typically expect. Some other factors is composition. So soil composition, we've got sand, clay, and silt are going to be the three types of soil particles out there. And so with that sand, we've got a lot of large soil particles. And in this situation, we've got a lot of air pockets. And so the water hits the ground and flows through those air pockets down into the soil surface very quickly. Now, in certain situations, though, we can have, again, those same sand particles out there with some air pockets, but we may have some clay also. And clay is smaller soil particles that basically fill up those air pockets. And so then we've got the water that hits the ground, and we may actually see some ponding. And this may degrade over the growing season. So initially you may have some fairly decent infiltration in, let's say, a sandy silt loam soil. But over time, especially as you get closer to when the crop is needing more water, let's say around the reproductive stage at the end of July, those clay particles are somewhat baked into the ground, and so it really those air pockets are decreased, and it can almost be somewhat of a concrete or a sandstone type of mixture out there, and really reduces the infiltration of the water when the crop actually needs it the most. Organic matter is something else that can be also influences infiltration rate. So if we've got let's say a half inch or a 0.5% of organic matter out there, Organic matter basically acts like a sponge. And so if you compare that to 2 to 3% organic matter, you've got considerably more a bigger sponge out there that's able to absorb that water compared to that 0.5%. So that organic matter again will absorb that water and allow for infiltration over time compared to that ground that only has a 0.5%, where you're going to see more runoff. What about soil moisture? So if you do have a light rain that goes through the area that basically wets the surface, you're going to see decreased infiltration rates compared to what you might expect, because again the ground was wetted at that time. Compaction zone. So compaction can definitely impede infiltration of that water, and so we're all guilty of maybe going out there a little too soon and planting our crops when the ground is wet after a rainfall. And you think of a row unit going through the ground along with our planter. We can see some surface compaction out there where the ground is pressed down and then it dries out, and we've got a fairly decent level of compaction near the soil surface, impeding the irrigation water from getting into the ground. We can also see this with a field cultivator, although it may be, if we go out there and work the ground when the ground is wet, the field cultivator is going to compact it maybe 4 to 6 inches below the soil surface compared to that surface compaction. This can also happen with a strip till. Strip till, we typically think we're going to open the ground up and not see, and it's going to improve infiltration, but it can actually reduce or cause some compaction out there if we go through there and strip till or rip the ground when the ground is too wet. So back to that compaction zone, if we do go through there and work the ground when the soil is dry, and we strip till that, so we're strip tilling it every 30 inches, and again the ground does have to be dry, but we are opening that ground up, and that's when we're causing breaks out there in that compaction zone. And so as the rainfall hits the ground, it will then run down into our areas that are strip tilled, and we will see more infiltration in ground that was strip tilled compared to ground that was not strip tilled, as long as we're doing that strip till application at the right time. But again, if we don't manage the compaction zone, we're going to see significantly less infiltration than what we would like to. Some other factors, we've got our irrigation system. There are different irrigation systems, and it really has to do with the wetted area. And so we've got our sprinkler systems. When we're looking at our impact sprinklers, we've got high pressure and low pressure, but the wetted areas on these systems are anywhere from 170 to 100 feet, and so the area is quite large, and so we can put out a large amount of water per nozzle and really have a large wetted area for that water to be infiltrated into. When we get into the LESA, which is the low elevation spray application system, or the LPIC, which is the low pressure in canopy systems, or LIPA, which is the low energy precision application systems, their wetted areas are going to be anywhere from 10 to 20 feet in diameter. And so this is represented by the blue line on the graph. This graph was actually provided to us by Dr. Terry Howell at the USDA ARS Center down in Bushland, Texas. He allowed us to use this for our irrigation handbook. And so it gives a good representation of the differences between impact nozzles and, again, the LESA or LIPA type of nozzles, where the wetted diameter is much less. And so when we're looking at, again, these LESA and LIPA nozzles, the wetted area, the application rate has to be less for these nozzles because, again, you've got more nozzles out there. And so farmers that are just using these types of nozzles for the first time, it's really, you really got to get used to using them. Otherwise, you're going to see a significant amount of runoff because you're trying to put out too much water through each one of these nozzles. And then lastly, application rate. This is the factor that can easily be adjusted by the farmer for each irrigation event. And it really needs to be, because it is the irrigation system is dynamic over the growing season. You cannot put on the same amount at the beginning of the season as you can in the middle of the growing season if you're going to meet the needs of that growing crop. And so you are going to want to put out more water as that plant gets into that high water use demand time frame during the early reproductive stage. And you've got to maximize that with the infiltration rate. So there's some things that we can do beforehand to try to maximize infiltration rate. Again, have residue out there on the surface. Maybe go through there and plant on the contour, and so when that residue is there from the previous crop, it is there on the contour of the field, and so that again will decrease the runoff of that water and allow for more infiltration. We can go through there and look at our irrigation mapping system for those areas that have a more of a steep incline. Maybe we decrease the amount of water that we're putting on those areas, but then we're going over those areas multiple times compared to the rest of the field where we're using a higher application rate per nozzle, but we're able to get a higher level of infiltration because again the ground is flat. So with that, again, these are just some basic irrigation principles we're discussing, and so I want to thank you for your taking a few minutes out of your day to spend with us, and we'll be talking to you in the future about other irrigation topics.
For more information on this topic, you can download the Monsanto Irrigation Handbook for the Great Plains by using the following address. This video was produced by the Monsanto Water Utilization Learning Center.